Hi, greetings everyone. Welcome to the first part of the video for section 6.5. We're now going to start looking at word problems related to the stuff we've been doing in this chapter. And I know some of these problems might look kind of familiar from stuff that you did earlier in section 6.1, but we'll take it to a little different level here. All right, so here in this problem, we're told that outside temperature can be modeled as a sinusoidal function. And we're told, suppose we know that the high temperature at 85 degrees occurs at 10 a.m. and the average temperature for the day is 75 degrees. And we need to find the temperature to the nearest degree at 9 a.m. Now, a couple of things I see in here. Number one, we're told that this can be modeled as a sinusoidal function, which means we're probably going to have to write an equation here. And because it's sinusoidal, we know we can either use a sine function. And so we would use this formula that sine of, or a times sine of b times t minus h plus k. Or cosine waves are also sinusoidal functions. So we might also instead use f of t equals a times cosine of b times t minus h plus k. So we'll keep that in mind as we're working on this. Also something we generally, when we're working on these types of problems that we accept, is the value for t will be time, and it's usually time after some point. And generally we'll use this as time after midnight. Okay, and that's useful for us because then we can say that time t equals 0. Well, that will always be midnight. And then t equals 1 would be like 1 a.m. T equals 2 would be 2 a.m. So on and so forth. So in fact, sorry, I said time here. I should have said hours after midnight. Okay. All right, the next thing I'm going to do to kind of help us with this is draw a graph here that's going to be kind of our diagram to help us figure out what's going on. And let's look at the information we're given in the problem. So we're told that the high temperature is 85 degrees, and that occurs at 10 a.m. So if you think about graphing this here on the graph, our highest point we're going to hit is 85. And that's going to happen at 10 a.m., which is 10 hours after midnight, which means we're looking at when t equals 10. Okay, so that's where we're going to hit that max temperature there. And then we're also told that the average temperature for the day is 75 degrees. Okay, so that means kind of our middle temperature between our max and min would be 75, which if that's the middle or the average, and our highest is 85, what will our lowest be? Right, that would be 65, right? Okay, so that's all the information we're given. Let's also think about what the shape of the graph here might be. Now we know it's sinusoidal, so we know it's going to look like a sine or a cosine. And since 85 is the highest temperature it reaches, it probably means that after that it's going to go down and then start to do something like this, right? We know our sinusoidal functions do. We also know that 75 looks to be the middle between our high and low, so that means that tells us about what about the function? Yeah, that should be where the midline is, which if I'd drawn this better, it would look like a midline. So let me try to do that better. So it looks something like this. Okay. And now let's see if we can figure out this information that we need for our function. So first of all, hopefully we can see that our amplitude here should be 10 units since the average is 10 units below the max and 10 units above the max. So we know our value for A would be 10. To find our value for B, we know we do 2 pi divided by the period. And what would the period be here? Well, we're talking about hours after midnight, talking about temperature throughout the day. So probably our period is going to be 24 hours, right? Because it's looking at like over a full day. So then, thus to find the value for B, we do 2 pi over 24, which will give us pi over 12. We already know the value for the midline. That's the average, so that would be 75. And now the big question, is this going to be sine or cosine? Well, it's kind of hard to tell, though. Note that the starting point we have here, kind of the point where we're told that the high temperature happens, that's at a max value, which is off of the midline, right? And we know in general that if we're starting a function off of the midline, then that's a cosine function. So we're going to use cosine here. Also notice that for this cosine function, if we choose that, the starting point is not on the vertical axis, right? It's been shifted over. And how much has it been shifted over? Well, it's been shifted over 10 units. So it looks like our value for h would be 10. Okay. So now with this information, we can find our equations. So that'd be f of t equals the value for a, which is 10, times cosine, the value for b, which is pi over 12, times t minus the shift, which is 10 units, right, plus 75. Okay. All right, and then to finally answer the question, because we haven't actually answered our question yet, we have to find the temperature to the nearest degree at 9 a.m. Well, recall again that our values for t here are hours after midnight, and 9 is 9 hours after midnight. So what we have to do simply is just plug in 9 for t. So we'd put a 9 in here, but not like that. Put a 9 in here, a 9 in here, and I'm sorry for the sake of space and time, I'm not going to write all that out. And then we can plug that into our calculator, make sure that we're in degrees mode radians mode, since here we use 2 pi, which is in radians. So do 10 times cosine of pi over 12 times 9 minus 10 plus 75. Looks like I get 84.659, which we're asked to round to the nearest degree, so that would be about 85 degrees. Which, actually the 84.659 makes more sense, right? Because 9 a.m. is before the max. We know the max happens at 10 a.m., so we should be pretty close to that. Okay? All right, that's it for now. Thank you for watching.